Hello friends and welcome to another tutorial on Geeks. In this video, we are going to understand the program which helps us in determining if a tree is height balanced. First, let us understand what exactly a height balanced binary tree mean. A height balanced tree is one where no leaf is much farther away from the root than any other leaf. An empty tree is height balanced. A non-empty tree T is balanced if left subtree of T is balanced, right subtree of T is balanced, and the difference between heights of left and right subtrees is not more than 1. Now, let us have a look at the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node which is 1 to function is balanced, so root will point to 1. We take two variables LH and RH to store height of left and right subtrees. Since root is not null, we get the height of left and right subtree of root. We assume that the height function is already created. So LH will be equal to 3 as the height of the left subtree is 3 and RH will be 2 as the height of the right subtree is 2. Now we check if the absolute value of LH minus RH is less than or equal to 1. Since 3 minus 2 is equal to 1, we now pass the left child of root recursively using a call stack. Next, root will point to the left child of 1 which is 2. We compute the heights of left and right subtrees of node 2. The left height of 2 will be 1 and the right height of 2 will be 2. We check if the absolute value of LH minus RH is less than or equal to 1. Since it is true, we pass the left child of 2 which is 4. So, root will now point to 4. Again, we get the left and right height of node 4. Since 4 is a leaf node, both LH and RH will be equal to 0. H is less than 1, we pass the left child of 4 which is null. Since root is pointing to null, we return 1. Next, we pass the right child of 4 which is also null. Since root is pointing to null, we return 1. 1 and 1 and 1 will return 1 and we finish execution for node 4. Now we pass 2's right child which is 5, so root will point to 5. We compute the left and right height of node 5. The left height of 5 will be 1 and the right height is 0. Since LH minus RH is 1, we call for the left child of 5, so root will point to 7. We compute the left and right height of node 7. Since 7 is a leaf node, both LH and RH will be 0. Since LH minus RH is 0, we call for the left child of 7 which is null. So root will point to null. Since root is null, we return 1. Now we call for the right child of 7 which is also null. So again root will point to null. Since root is null, we return 1. Now 1 and 1 and 1 will return 1 and we finish execution for node 7. Next, we pass the right child of 5 which is null. So root will point to null. Since root is pointing to null, we return 1. Again, 1 and 1 and 1 will return 1 and we finish execution for node 5. Also, we finish execution for node 2 and return 1. Next, we pass the right child of 1 which is 3, so root points to 3. We compute the left and right height of node 3. The left height of 3 will be 0 and the right height is 1. Since absolute value of LH minus RH is 1, we call for the left child of 3 which is null. Since root is pointing to null, we return 1. Now we pass the right child of 3 which is 6. So root will point to 6. Since 6 is a leaf node, the left and right height will be 0. As LH minus RH is less than 1, we call for the left child of 6, which is null. Hence, root will point to null. Since root is null, we return 1. We call for the right child of 6, which is also null. Again, since root is pointing to null, we return 1. 1 and 1 and 1 will return 1, and we finish execution for node 6. Again, we return 1 and finish execution for node 3. Finally, we return 1, and hence this is a height balanced binary tree. Now let us see the time complexity of the program. This code will run in big O of n square complexity. Here n are the number of nodes in the binary tree. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.